Okay, so what did you get when you solved this equation for dy dx? We want to bring all the terms not involving dy dx to the right-hand side. So to undo adding this 1, we subtract 1 from both sides. We want to bring the 2y dy dx to the left because we're adding it on the right. So we want to subtract to bring it to the left. We want to bring all terms with dy dx to the left-hand side. Notice this is exactly the steps that we used on the previous Pencast when we solved 1 plus z equals az for z. Exactly the same steps. Now, we want to write dy dx just once, but it's written twice here. So I'll factor out a dy dx. I get 1 minus 2y. When you multiply dy dx by 1, you get dy dx. When you multiply dy dx by negative 2y, you get negative 2y dy dx. Now, something that's very important is that you realize this is dy dx times 1 minus 2y. It's not the derivative of 1 minus 2y. Okay, it's very important that you write these symbols correctly. You've got to realize that's multiplication. Okay, to undo this multiplication, I divide. So here's my answer. Derivative of y with respect to x is negative 1 over 1 minus 2y. Now, what you'll notice with implicit differentiation is your answers often have the variable y in them. Sometimes they'll have both the variables x and y in them, sometimes just y. Okay, that's something a little bit different with implicit differentiation. Now, let's use this result to find the slope of the line tangent to the graph of our equation, x plus y equal 3 plus y squared, at the point 3, 1. Is the point 3, 1 on this really on the graph? 3 plus 1, if I let x be 3 and y be 1, I get 3 plus 1 equals 3 plus 1 squared. Yes, that's true. So, sure enough, the point 3, 1 is on this graph. Here's the point 3, 1. Okay, so at the point 3, 1, derivative of y with respect to x is negative 1 over 1 minus 2 times 1. Where does that 1 come from? It comes from the fact that the y coordinate of the point's 1, and I'm using this. Okay, so at the point 3, 1, dy dx is negative 1 over negative 1, which is 1. So let's see if that looks right. Let's draw the line tangent to the graph at the point 3, 1. Does it look like the slope is 1? Does it look like the rise equals the run? Sure enough, the rise over the run at that point does seem to be approximately 1.